Functions, page 15. Number 5, comment on the results from 3E and F. So let's go back to the last page and let's look at what 3E and F are. 3E and 3F were these two unusual inverse functions where the function itself and the inverse function are the exact same function. So that's what we're going to comment. We're going to say for 3E and F, the function was equal to the inverse function. Okay? And then it says, draw a linear function that is a self-inverse function. Okay? So remember, a self-inverse function has to have itself as an inverse. So, I mean, you're very limited. You could draw one that looks like 3E, or you could draw one that looks like 3F. In 3F, there's only one combination. For 3E, the only thing you can vary is you could draw it here, you could draw it here, you could draw it like multiple places, but it's still going to kind of look the same. Okay? So that is B. C, draw a rational function other than y equals 1 over x that is a self-inverse function. Okay, so y equals 1 over x, remember, looks like this. Okay, and that, of course, is also a self-inverse function. Now it says to draw one another one that is not that one. Well, how about like let me draw like this color. Okay. How about like that? That's different. Okay. By the way, the equation for this is something like that, so it's pretty close. If the domain h of x is between -2 and 3, including -2, state the range of h of inverse function of h. And remember, the ranges in the domains are the opposite. So, like, if they say the domain of h is that, then the range of inverse h is going to be exactly the same thing, except for instead of all the x's, you're going to have y's. 7. Given that f of x is this function, find the inverse function. Okay. Now, I already know what's going to happen, but in case you don't know the surprise, I'm going to go ahead and work through it. Okay. So you do variable interchange, and you get x equals 2y minus 5. 2y is equal to x plus 5. Y is equal to 1/2 x plus 5. Okay? So this is the inverse function here. Now let's take the inverse function of the inverse function. We're going to get x equals 1/2 y plus 5, and we're going to solve for y now. So we're going to have 2x equals y plus 5, and then we'll have y equals 2x minus 5, and what do you know? We get the same thing back. So what do you notice? You get the same thing back. Okay. 8. Sketch the graph of the function x cubed and its inverse function. Okay. X cubed, you can like graph out a few points just in case you don't remember. 0 goes to 0. -1 goes to -1. 1 goes to 1. -2 goes to -8. 2 goes to 8. So we can graph a few points here. So 2 goes to 8. -1 goes to 1. -1. So it looks kind of like that. Something like that. And then its inverse function would be, just rotate it, not rotate it, but reflect it about this axis. And so what you're going to get is, okay, like that, and like that, something like that. Okay? Alright. 9. Given that the function is 1 over x, x cannot be 0, find the inverse function of f algebraically and show that it is a self-inverse function. Okay, So we have y equals 1 over x, and all we're going to do is do variable interchange, x equals 1 over y, and then we're going to solve for y, and we'll get y equals 1 over x. Hey, what do you know? Look at that. The inverse function is itself, so it's self-inverse function. Okay, that was 9. 10. Show that the function 3x minus 8 over x minus 3, where x is not equal to 3, is a self-inverse function by reference to its graph and using algebra. Let's do algebra first. Y equals 3x minus 8 over x minus 3. Wow, is that a self-inverse function? You can't really tell, right? So first thing you're going to do is variable interchange. Okay, and then we're going to solve for y. First we're going to multiply both sides by y minus 3. Get it out of the denominator. Then we're going to multiply it out. Xy minus 3x equals 3y minus 8. And then we're going to combine the y terms. Xy minus 3y equals 3x minus 8. And then we're going to factor out the y. And then we're going to divide both sides by x minus 3. And what do you know? We got the same thing back. So it's also a self-inverse function. Now let's graph it, and then we can see graphically why it's a self-inverse function. Okay, so let's where are the intercepts? We're going to draw the intercepts in light green. The intercepts, the asymptotes. The vertical asymptote is at x equals positive 3. And the horizontal asymptote, if you put a huge number in for x, you're going to get like 3 million over 1 million, which is 3. So the horizontal asymptote is 3 when you're going to the right. When you're going to the left, it's also 3. And then let's find like the y-intercept. If we put 0 in for x, we're going to get negative 8 divided by negative 3, which is 8/3. Which is about 2 2/3 positive. So that would be like here. So we can already see that it's going to be a hyperbola like that. And if this one's down here, this one's up here. Okay. And then like say, okay, now what if we did a what if we did a reflection about the identity function? We're going to get the exact same function, right? So that's how we prove that it is a self-inverse function. We show that it is symmetrical about the identity function.